In this video, we will talk about the variations of the electrostatic force. We will see how the electrostatic force becomes stronger or weaker. What are the factors that affect the electrostatic force strength? According to Coulomb's law, the electrostatic force Fe is directly proportional to the product of the magnitude of the charges, and it is inversely proportional to the square of the distance separating the charges. So the first factor affecting the strength of the electrostatic force is the amount of charges carried by each object. The more the amount of a charge is, it means the greater the force will be. So the electrostatic force is directly proportional to the amount of charges, as we mentioned at the beginning. The second factor is the distance separating the charged objects. The more the distance means the weaker the force, or the less the distance means the stronger the force. Let's see how the variation takes place. The electrostatic force between two charged objects of charges Q1 and Q2 separated at a distance r. So we have Q1 and Q2, they are separated at a distance r. The force between them is 25 newtons. Find the force between the two objects if the charge on each object is doubled. The original force between the two charges is Fe Kc Q1 Q2 over r squared. Now, it's mentioned in the question that both charges are doubled, so the new charge Q1 is double of the original one, so it's 2Q1, and the new charge Q2 will be double of the original charge Q2, so 2Q2. Then the new force will be as follows. I'll call it Fen, means the new electrostatic force is equal to Kc. Instead of Q1, I write 2Q1 because it is doubled. Same thing for Q2, it is 2Q2 now. So the new electrostatic force, we have 2 and 2. Their product is 4. I take it out. So 2 times 2 is 4. I take it out. So it becomes 4 Kc Q1 Q2 over r squared. Now, okay. Kc Q1 Q2 over r squared is the same as this part, which is the same as the original force Fe. So the new electrostatic force will take this form. The new electrostatic force is equal to 4. Instead of writing Kc Q1 Q2 over r squared, I will replace it by Fe. So 4 Fe. If we replace 4 times 25, it gives 100 newtons. Then the force is increased by a factor of 4. So again, what we do is the following. We write the original formula of the electrostatic force according to Coulomb's law. Then we replace with the variations. The first charge is doubled, the second charge is doubled. We write 2Q1, 2Q2, and we continue the calculations. Another exercise. The electrostatic force between charged objects of charges Q1, Q2, and separated at the distance r, so we have the same initial conditions. The force between them is 80 newtons. Find the force between the two objects if the separation distance between them is doubled. The original formula from Coulomb's law, Kc Q1 Q2 over r squared. If the separation distance is doubled, it means that the new distance is 2r. So the new electrostatic force is equal to Kc Q1 Q2. There's no change in the magnitude of charges, but we have a change in the distance. It is 2r, all of it to the power of 2. This is a common mistake. Do not write 2 multiplied by r squared. No, it is 2r all squared. Why? Because in the question they mentioned that the separation distance is doubled, not the square of the separation distance is doubled. So instead of r squared, we'll have 2r all squared. 2 is 4 and r squared is r squared, so 2r squared becomes 4r squared. I take 1 over 4 out of the force. Same thing, this is the original force, as you see, Kc Q1 Q2 over r squared, which is Fe. Then the new electrostatic force is equal to Fe over 4. If we replace 80 over 4 is 20 newtons, then we can say that the force is decreased by a factor of 4. Another example. The electrostatic force between two charged objects of charges Q1 and Q2 separated at the distance r is 180 newtons. Find the force between the two objects if the separation distance is tripled and the charge on one of the objects is doubled. Let's see. The separation distance is tripled, so the new distance is 3r. The charge on one of the objects is doubled. I will double Q2. I can double Q1. Since they did not mention which one was doubled, you can double any one you want. So when we replace, the new electrostatic force is equal to Kc Q1. I mentioned that I doubled the Q2, so instead of Q2 we write 2Q2 over 3R, all of it squared, between brackets, all squared. Fen Kc Q1 2Q2, 3 squared is 9, so we'll have 9R squared. Take the 2 out and take the 9 out. You'll have it as a fraction 2 over 9 Kc Q1 Q2 over R squared, which is the same as the original electrostatic force. So 2 Fe over 9, when you replace 2 times 180 is 360 over 9, it gives you 40 newtons. Okay. The force is decreased by a factor of 2 over 9. How do we know? The force was 180. It became 40, so it decreased. By what factor was that change? As we see in this part, it is 2 over 9. The electrostatic force between two charged objects of a charged Q1 and Q2 separated at a distance r is 90 newtons. So we have the same initial conditions, Q1, Q2, and r. Find the force between the objects. If the separation distance is tripled, the charge on one of the objects is doubled, and the charge on the other object is increased by a factor of 5. So we have 3 variations in this case. We write the original formula of Coulomb's law, Fe equals Kc Q1 Q2 over R squared. Now, let's write the variations. The separation distance is tripled. It means that the new distance is 3r instead of r. The charge on one of the objects is increased by a factor of 5. They did not mention which object, so I chose Q1. So the new charge Q1 is 5 multiplied by the original Q1. The charge on one of the objects is doubled. Same thing, they didn't mention. I chose Q2, so the new charge Q2 is double of the original charge Q2. How to replace? Instead of Q1, I write 5Q1. Instead of Q2, I write 2Q2. Instead of R, I write 3R. So I replace the variations in the formula. Okay, so 5Q1, 2Q2, as we see. 3R, all of it squared, it becomes 9R squared. So the new variation will be 2 times 5 is 10, I take it out, and I take the 9 out, so we have a fraction 10 over 9. Again, this is the original formula of Coulomb's law, so this is Fe. It means that Fe, the new one, is 10 over 9 multiplied by the original Fe. If you do the calculations, you will get 100 newtons. So as you see, it was 90, now it's 100. The force is increased, so it is increased. We can know from this 90 to 100. By what factor? 10 over 9. Here you can see some real-life examples of different electrostatic forces that exist around us in real life.